In this video, we are going to explain about using TensorFlow libraries in implementing the deep belief network method on MNIST dataset. Deep belief networks have already been coded many times before because of its importance. Here we have used the modules that have already been written. I have written the reference of the DBN module on top of the Python file, and I encourage you to take a look at different examples that they have in their repository. I have also included a DBN zip folder for you. So here, in this part of the code, you are able to see the reference and the citation, which can help you explore more examples about DBN. In this part of the code that you can see, we have imported required libraries like Pickle for storing the data and keeping track of the model for future references, Matplotlib for showing the data, scikit-learn modules such as linear model for loading logistic regression as the final estimator of the DBN, and metrics for evaluation and report, and also pipeline with a series of transforms and a final estimator. The unsupervised DBN module is loaded from the DBN folder included. The MNIST dataset is loaded from the TensorFlow library. Here you can see that the MNIST dataset is loaded from the TensorFlow library that we have already imported. In this part that I'm showing, the training and the test datasets with their labels are separated, and we have easily shown the image of one of the samples, but we must keep in mind that we have to reshape the image in order to see it. It is reshaped to 28 times 28 because it is already vectorized. So here you can see the image of one of the samples. The regularizer parameters are defined here, as you can see. As we make them smaller, we are forcing stronger and stronger regularization. Then we have loaded the logistic regression module as the final estimator with its parameters like what I have already defined here above. So if we scroll, you can see all of the inputs and arguments that it's receiving. The algorithm which is used on the optimization is called the solver, and we can see that Newton solver is chosen here. The DBN model is made in which the structure of the hidden layers, this is the DBN model that I'm talking about. So the structure of the DBN model is, as I will explain right now, this model has 256 inputs and 512 outputs. The number of the samples that each time we feed the model with is set to 100, which is called batch size here. The learning rate of the RBM or restricted Boltzmann machines that are used in this example is set to 0.01, and the number of the epochs is like optional, so we have just chosen 10 here, but you can change it to higher numbers. So the classifier that we can make with the use of a DBN consists of a DBN and a logistic regression which are connected in a pipeline serially, as you can see here, for making them serial. Then we feed the classifier with the training data, which will start training the RBMs. The logistic regression will also be trained by the same data, as you can see here. In the previous part, we had the training of the restricted Boltzmann machines, and here you can see the training of the logistic regression. Then the model is saved as a pickle data object with the pkl extension in the folder that we have the code in. We can reload the same model in the future by reloading that pickle file. The evaluation of the DBN, which helps the pre-training of the logistic regression classifier, is printed afterwards and the test data is used. So in this part, you can see the pickle function that we have used in order to save the data for the future use. And then we have printed the evaluation and the evaluation of the performance of the code that we have written. So here you can see the results and the metrics, the evaluation metrics that are used here. The precision, for example. And here you can see that in each epoch we have the error, and as we are going through more and more epochs, we can see that the error is just decreasing. So if we increase the number of the epochs, most probably we would get more accurate results. Great! Thanks for your attention. So now we are done with implementing a very simple and basic use case of a DBN in pre-training a classifier. This is what a DBN is meant to be. It is made to help the classifiers because they mostly have the training problem of vanishing gradients, but pre-training can improve the results in that case.